Welcome to qnawire.
Okay, so here you're given a car that's moving in a direction with speed v1 and mass m, and then you have another car moving in the same direction with speed v2 and mass 2m, and you're told that they collide, and then finally they each move with the same speed because they're now stuck together, v final. And you have to calculate this final velocity, and you have to calculate the change in kinetic energy. So in this case, we're going to use momentum equations first, because pi again is equal to pf regardless of what collision it is. This is going to be an inelastic collision because these things stick together afterwards. So the total mass here will be 3m because it's 2m plus m since they got stuck together. So for pi, it's just going to be m v1 plus 2m v2 should be equal to 3m v final. And if you simplify this, you realize that v final is actually equal to, again, this m is common to both expressions, so I can just cancel that. And then this should be v1 plus v2 over 3. So that's your final velocity there. Unless you're given any one of these two, you cannot solve for the value of vf. And in this case, you'd have 3 unknown variables here. So you will not be able to calculate the v final numerically because you need 3 different equations to solve for this. So now the next part, this thing wants you to calculate the change in the kinetic energy, but that's just the kinetic energy that you had initially minus the kinetic energy that you're going to have at the end. And this equation essentially becomes, again, the kinetic energy initially was just half m v1 squared plus half 2m, again this is 2 v2 squared. I wrote the 2 here because it's 2m, minus this final kinetic energy here, which is half of 3m v final squared. And notice that now this is just calculating the change in kinetic energy here. So now you go on to simplify this. So we know that, so here you can go ahead and remove that 2 there. And we know what this is in terms of v1 and v2. So if you want, you can just go ahead and plug that in to simplify it further. So that's now mv2 squared minus 3 over 2m, and then in place of this I just put v1 plus, actually this is supposed to be 2v2 here, v1 plus 2v2 over 3 squared. That's equal to delta k. And then now you go ahead and simplify this a little further if you want. So we know, again, this is going to be mv1 squared over 2 plus mv2 squared minus, so I can go ahead and simplify this, remove this over here, which gets me m over 6. And then now you work on this bracket here, which is going to give you v1 squared plus 4v2 squared plus a cross term here, or two cross terms when you multiply these two together, which is going to give you 4v1 v2, like that. And you can then now see that you have this term and this term in common, this term and this term in common, and then a cross term here. So we can go ahead and again simplify that even further. So in this case, you have half mv1 squared and 1/6 mv1 squared. So if you subtract those, you notice that it's going to give you, so this can be 3/6 minus 1/6 here, which is 2/6, which is a third. So this is a third mv1 squared. And this is, again, 6/6 minus 4/6, which is, again, 1/3. So plus mv2 squared, a third. And then the cross term, which is now 2/3. 2/3 of v1, v2 multiplied by the mass. So notice you can still simplify this further. So if you write that as a third m, you have v1 squared plus v2 squared minus 2v1 v2. And that can be your delta K. And you can even go ahead and write this as a square of a sum v1. So this can be v1 minus v2 in bracket squared, but that's not. So this would be your change in kinetic energy, and that's your final velocity. And that's it.